Welcome to another deep dive into the world of AI.
Yeah.
And today we're going to be talking about model efficiency.
Yeah.
And specifically, we're going to be unpacking a paper called TinyFusion Diffusion, Transformers Learned Shallow,
Okay.
which is such a cool title, by the way.
Yeah, it is.
And, really tackles this challenge that feels pretty universal. Like,
Right.
what if you have this super powerful tool,
Mm-hmm.
but it just takes forever to actually use it?
Oh, yeah,
That's the problem with a lot of cutting-edge AI right now,
for sure.
especially when it comes to generating images.
Yeah.
These models, they're amazing,
Yeah.
but they can be so huge and complex that they're really slow
Right.
and expensive to run.
Yeah. And that's a major bottleneck.
Totally, and that's where TinyFusion comes in.
Exactly.
It's promising us a way to make these powerful AI models faster and more efficient
Yeah.
without sacrificing too much quality.
Yeah. That's the key.
So that's what we're going to be figuring out today,
Correct.
how TinyFusion pulls this off.
Sounds good.
Okay, so let's set the stage here.
It's talking about diffusion transformers,
Yeah,
which are a type of AI model
right.
that's really good at generating images, but they can be absolutely massive.
Yeah, they can.
These models have tons and tons of parameters,
It's crazy.
and all those parameters.
Yeah.
Now they need a lot of computing power just to run.
Right, a lot of resources.
Yeah, it's kind of like having this fancy sports car
Okay.
with a huge engine, you know?
Yeah.
Sure, it's powerful,
Mm-hmm.
but it guzzles gas like crazy.
Oh, yeah, for sure.
And that's a problem if you want to use these models for, practical applications.
Right, exactly. It's not very sustainable.
Exactly.
Yeah,
And you might be thinking, can't we just make the models smaller?
right.
And the answer is yes, to some extent.
Yeah.
There are some existing methods for compressing models,
Mm-hmm.
like reducing their width,
Yeah,
essentially trimming down the number of neurons they have.
right. Fewer connections.
Yeah, but those methods have their limits.
Definitely.
And this brings us to TinyFusion.
And its unique approach.
Oh, wait.
So instead of just shrinking the models with,
Yeah.
TinyFusion focuses on pruning away entire layers of the model
Oh, wow.
to make it shallower.
Interesting.
And what's really interesting here is this concept of recoverability.
Oh,
The idea that some pruned models have a greater ability to bounce back
mm-hmm.
and regain their performance with just a bit of fine-tuning.
I see. So they have this potential to adapt.
Yeah, exactly.
That's
This
fascinating.
is not just about making it smaller.
Right.
It's about finding the models that have that potential to be almost as good as the original, even after being significantly trimmed down.
That's really clever.
Yeah, it's like finding a plant
Okay.
that can not only survive being pruned,
Mm-hmm.
but actually flourish afterwards.
Yeah, I like that analogy.
So how does TinyFusion actually find these resilient models?
Well, it uses a pretty clever combination of techniques.
Okay.
First, it breaks the large model into smaller blocks
Okay.
to make it easier to analyze.
Makes sense.
Yeah, and then it applies a method called differentiable sampling.
All right.
Think of it as running a series of experiments,
Okay.
trying out different combinations of layers to remove,
Mm-hmm.
and seeing how well each combination recovers its performance.
So it's like trial and error, but in a more systematic way.
Exactly. And here's the really cool part.
Okay.
TinyFusion doesn't actually have to fine-tune every single pruned version.
Oh, wow.
Instead, it uses these clever estimation techniques,
Mm-hmm.
like something called LoRa,
Okay.
which stands for low-rank adaptation,
Mhm.
to quickly get a sense of how well a particular pruned model would perform after fine-tuning.
So it's like looking into a crystal ball,
Yeah,
getting a preview of which pruned models have the best chance of bouncing back with some additional training.
exactly. It's like a sneak peek into the future.
I love that. And this focus on recoverability is what sets TinyFusion apart, right?
It is. It's not just about minimizing the immediate performance hit after pruning,
Right.
but finding models that have the potential to regain their performance over time.
And the results speak for themselves. I mean,
Yeah.
the paper talks about TinyFusion achieving some pretty impressive results.
Right.
Sometimes even outperforming larger models while being much faster.
Absolutely. They found that simply minimizing the initial loss after pruning didn't always lead to the best final performance.
So you really need to consider that long-term potential.
Exactly. That's why TinyFusion's focus on recoverability is so crucial.
Okay, that makes a lot of sense, and I know there's another trick up TinyFusion's sleeve.
Oh, yeah.
Something called knowledge distillation,
That's right.
which I think we should dive into a bit more.
Okay.
Well, maybe we can take a quick break and come back to that.
Sure, sounds good.
All right, so before the break, we were talking about knowledge distillation.
Right. That secret sauce.
Yeah, exactly. But I have to admit, my brain is still a little bit fuzzy on how TinyFusion actually works.
Yeah, sure.
On like a technical level, you know?
So imagine you're trying to find the perfect combination on a lock.
Okay.
With multiple dials.
Mm-hmm.
You could try every single combination one by one,
Right.
but that would take forever.
Yeah, that wouldn't be very efficient.
Exactly.
Yeah.
So TinyFusion takes a more efficient approach.
Okay.
It treats the pruning process like a probability problem.
Interesting.
Yeah, it starts by assuming all layer combinations are equally likely,
Okay.
but then it uses its experiments
Mm-hmm.
to refine those probabilities.
So learning as it goes.
Exactly. It's learning which combinations are most likely to lead to good recoverability.
So it's like it's learning to crack the code of which layers are the most important to keep.
Exactly. And this learning process is powered by something called differentiable sampling.
Okay, that sounds complicated.
Yeah, this is where it gets a bit technical.
All right.
But essentially, it allows TinyFusion to use a powerful optimization algorithm
Mhm.
called gradient descent
Okay.
to figure out the best pruning strategy.
So it's not randomly chopping off layers.
No, it's not. It's
Yeah.
being very strategic.
That's pretty cool. But what about the recoverability estimation?
Right.
How does TinyFusion know if a pruned model will actually bounce back with fine-tuning?
So that's where things get really ingenious.
Okay.
Instead of actually fine-tuning every single pruned model,
Right.
which would be incredibly time-consuming.
Yeah, I can imagine.
TinyFusion uses techniques like LOR-R,
Okay.
which stands for low rank adaptation,
Uh-huh.
to quickly estimate how well the model would perform after fine-tuning.
So it's like looking into the future
Yeah, kind
to
of.
see which pruned models have the most potential.
Exactly. It's a shortcut to figure out which models are worth investing more time in.
That's so smart. Okay, let's go back to knowledge distillation for a moment.
Okay, sure.
So we touched on it earlier, but I want to dive a little deeper.
All right.
Because this idea of a student model learning from a teacher model is just fascinating to me.
Yeah, it's a really cool concept.
But I'm still not quite clear on how it actually plays out in practice.
So think of it this way. The student model is trained to mimic the behavior of the teacher model.
Okay.
We feed both models the same input data
Mm-hmm.
and then compare their outputs.
Got it.
And the student model is essentially trying to produce the same results as the teacher,
Okay.
even though it has a much simpler structure.
So it's like the student is trying to learn the teacher's secrets
Yeah, exactly.
to figure out how to achieve that same level of mastery, but with fewer tools.
Precisely. But here's the key.
Okay.
TinyFusion uses a specific type of knowledge distillation called masked knowledge distillation.
Okay.
This means it focuses on matching the internal workings of the two models.
Not just the final output.
Right, exactly. It's like making sure the student understands not only the what,
Mm-hmm.
but also the how.
So it's not just about getting the right answer.
No,
It's about understanding the reasoning behind it.
you got it.
That makes a lot of sense.
Okay.
But let's get down to brass tacks here.
All right.
Does TinyFusion actually deliver on its promises?
So the results are actually quite remarkable. In their experiments, the researchers found that TinyFusion consistently outperformed other pruning methods,
Oh, wow.
achieving both better performance and faster inference speeds.
So it's like a win-win.
Yeah, pretty much.
That's awesome.
Yeah, for instance, they took a large diffusion transformer model called DiTXL
Okay.
and pruned it down to just 14 layers,
Wow.
creating a model called TinyDTD14.
TinyDTD14.
Yeah, and this smaller model was not only significantly faster,
Okay.
but also achieved a better FID score
Which is...
than the original DiTXL.
Wait, so you're telling me the smaller model is actually producing higher quality images
Yeah.
and doing it faster?
And doing it faster. That's the amazing part.
That seems counterintuitive.
It might seem that way, but that's the beauty of TinyFusion.
Yeah.
It really challenges our assumptions about the relationship between size and performance in AI.
It's like less is more.
Yeah, in a way.
I love that. And then these results weren't just limited to DiTXL, right?
Right. They saw similar improvements when they applied TinyFusion to other diffusion transformer models,
Okay.
like MRs and SITs.
So it's not a fluke?
No, it's not. This
Yeah.
approach seems to have real potential.
Okay, so this is all very exciting.
Yeah.
But what does this mean for the average person?
Right.
Why should we care about making AI models smaller and faster?
Well, imagine being able to run powerful AI models on your smartphone,
Oh, wow.
or having AI assistants that respond instantly,
Yeah.
or even using AI to personalize your healthcare in real time.
Yeah, that'd be incredible.
Yeah. So TinyFusion takes us closer to a world where powerful AI is no longer confined to massive data centers,
Right.
but can be seamlessly integrated into our everyday lives.
That's a pretty compelling vision.
Yeah.
I have to ask, though, are there any downsides to this approach?
That's a great question, and it's something the researchers addressed in the paper.
Okay.
So while TinyFusion demonstrates these impressive results, it's important to remember that there will always be trade-offs. In some cases, the smaller models might not be able to achieve the absolute peak performance of the originals.
Okay.
However, the researchers found that these differences were often minimal,
Mm-hmm.
especially when considering the gains in speed and efficiency.
So it's all about finding the right balance.
Exactly, finding the right balance for the specific application.
Okay, that makes sense. So it's not a one-size-fits-all solution,
Right.
but it's a powerful tool in our arsenal as we strive to make AI more efficient
Yes,
and accessible.
definitely. I'm curious, what are your personal thoughts on this research?
Oh, that's a good question.
Yeah, what excites you the most about TinyFusion?
Well, I think what I find particularly fascinating is that TinyFusion isn't just about making AI models smaller.
Mm-hmm.
It's about changing the way we think about AI development.
I agree.
It challenges us to consider whether bigger is always better
Yeah,
and encourages us to explore these more elegant and efficient solutions.
for sure.
It's a reminder that sometimes the most profound breakthroughs come from rethinking our assumptions and finding new ways to approach old problems.
I love that perspective. It's not just about the technical achievement,
Right.
but about the shift in thinking it represents.
And that brings us to another interesting question.
Okay.
So if TinyFusion works so well for image generation,
Yeah.
could similar techniques be applied to other types of AI models,
Right.
like those used in language processing or even robotics?
That's a question that's on the minds of many researchers right now.
I bet.
Yeah, the success of TinyFusion has certainly sparked a lot of interest
Mm-hmm.
in exploring similar approaches for other domains.
That makes sense.
And early indications suggest that these techniques hold a lot of promise.
Oh, wow.
Imagine a world where we have powerful language models that can run on our phones,
Right.
or robots that can learn and adapt much more quickly thanks to more efficient AI.
Yeah.
The possibilities are truly exciting.
Yeah, it really is exciting to think about all the different ways that this research could be applied. Like we've been talking about faster image generation, slicker AI assistance. But where else could this lead?
I mean, the possibilities are really endless.
Yeah.
We could see AI becoming more accessible to everyone,
Right.
not just those with access to these huge computing resources.
Yeah, exactly. Like, are we talking about a future where I could have cutting-edge AI on my phone?
Exactly. TinyFusion is really pushing us in that direction.
That's amazing.
Yeah, it's making it possible to run these powerful models on devices that are more readily available,
Right.
like smartphones or even embedded systems.
So it's not just about making things faster.
Right.
It's about making AI more democratic.
Absolutely.
I like that. And that opens up a whole new world of possibilities for, AI-powered applications.
Yeah.
It feels like healthcare,
Education.
even personalized creative tools.
Exactly. Imagine a world where anyone with a smartphone can access cutting-edge AI capabilities.
That's incredible. But let's zoom out for a second
Okay.
and think about the bigger picture here. So if we can achieve such remarkable results
Mm-hmm.
by shrinking these large AI models,
Yeah.
what does that tell us about the nature of intelligence itself?
That's a really deep question.
Yeah. Do we really need these massive, complex systems to replicate human-level intelligence?
Right.
Or can we find, more elegant and efficient solutions?
I think TinyFusion's research kind of indirectly addresses that
Okay.
by showing that we can achieve these impressive results with smaller, more streamlined models.
Right.
It challenges our assumptions about the link between size and intelligence.
So maybe bigger isn't always better.
Yeah, perhaps true intelligence, whether it's artificial or biological, lies not in sheer scale, but in elegant efficiency.
Like doing more with less.
Exactly.
I like that. And that brings us back to one of TinyFusion's core principles, right? This importance of recoverability.
Right. It's not just about shrinking models.
Yeah.
It's about identifying models that can adapt,
Yeah.
learn, and flourish even in a more constrained environment.
And that resilience, that ability to bounce back from pruning could be a key indicator of a model's potential for true intelligence.
It's like a test
Yeah.
to see how well they can adapt.
It reminds me of the way athletes train.
Oh, yeah.
They push themselves to their limits.
Right.
They're forcing their bodies to adapt and grow.
And in that process, they unlock all this hidden potential.
Exactly. And these smaller models,
Yeah.
they benefit from that knowledge transfer that's provided by their larger counterparts.
Right. That masked knowledge distillation process is so crucial.
Yeah, it helps them regain their performance
Hmm.
and even exceed their initial capabilities.
It's a beautiful example of collaboration
Yeah.
and knowledge sharing.
Even in the realm of artificial intelligence.
Yeah, the larger models are actually helping the smaller models succeed.
That's amazing. It highlights another important aspect of TinyFusion, right?
Hmm.
It's not simply about creating smaller models for efficiency's sake.
Right.
It's about exploring new ways to train and develop AI.
Exactly, leveraging the strengths of both large and small systems.
Yeah, because different types of intelligence have their own strengths and weaknesses.
Of course.
The larger models might excel in raw power and complexity,
Mm-hmm.
while the smaller models, you know, they shine in their efficiency and adaptability.
Right. And by weaving these different approaches together,
Yeah.
we can create AI systems that are even more powerful and versatile.
I love that. And as we wrap up our deep dive into TinyFusion,
Yeah,
I'm left with a sense of awe at the ingenuity of these researchers
for sure.
and just excitement about the possibilities that this research unlocks.
Yeah,
It feels like we're on the cusp of a new era in AI,
I agree.
one where efficiency and accessibility are no longer afterthoughts,
Mm-hmm.
but are woven into the very fabric of these powerful tools.
Couldn't have said it better myself.
Well, thank you so much for joining us on this deep dive into the world of TinyFusion.
It's been a pleasure.
We hope you've enjoyed exploring this groundbreaking research with us.
And until next time, keep exploring, keep questioning, and keep pushing the boundaries of what's possible with AI.